Lesson 9.8 is comparing linear, exponential, and quadratic models. So those are the three types of models that we've actually dealt with this year. And we spent a lot of time first semester and a little bit the second semester dealing with linear functions. And the form for the linear function is slope-intercept form. We can put it in multiple forms, but the basic form that we always use to look at the slope and y-intercept is slope-intercept form y equals mx plus b. Next we went into the exponential function, and that was y equals a times b to the x. A was the y-intercept, and b was that rate of change, the multiplier. And then finally we went into the quadratic function, y equals ax squared plus bx plus c. The a tells us whether it opens up or down. It does affect how narrow or how wide it is. The b, you may not know this, but it does help it move left and right. And then the c value is the y-intercept. And today we're going to be looking at multiple representations of these three different types of functions, and you're going to have to decide which function does the data represent. Okay, so the first thing you're going to have to do is you're going to have to graph them and decide based on the graph, is it linear, is it exponential, or is it quadratic? So this shouldn't take you very long, and I'm going to go ahead and plot the first one out, and then the second one I'm going to plot out, but I'm going to pause and do it so I don't take so much time. So we have -4, and 1/32 is almost right on the x-axis. -2 and 1/8 is up a little bit more. 0 and 1/2. 2 and 2. And lastly 4 and 8. And hopefully you can clearly see that this is increasing at an increasing rate, and it does fit the model for an exponential. I'm going to go ahead and graph the other two, so if you want to pause and graph it, that's fine, but you're going to see that when I come back it's already done. Okay, I have graphed these, and hopefully you can clearly see the second set of data is linear and the third set of data is quadratic. So you'll have a few of these to do for your assignment. You just simply plot the points and then look at the pattern and see what it is. Next, here I want to go over this explanation of differences and ratios. A table of values represents a linear function if the differences of the successive y values are all equal. A table of values represents an exponential function if the ratios of successive y values are all equal. In both cases, the increments between successive x units or x values need to be equal, so that's very important. And we'll look at that in just a minute. Basically, linear, if when you look to see the difference between the y values, they're the same. Exponential if the ratios are the same. It goes from maybe 25 to 5 to 1, and then that ratio is going to be 1/5 because you're dividing by 5 every time. Quadratic is a little different. Now yes, if you're given enough of the table, you can see that this is going to be a quadratic because you can see that it's going to be symmetric over the vertex. However, I still want you to be able to show me this rule here on your tables, because you're not always going to be given a full table that includes the vertex, and you're going to be asked eventually, what is it? So the first thing you do is you look at the differences, and I can see clearly this is not exponential because it does not have equal ratios. When I do the first differences, I get -3, -1, 1, and 3. So that shows me that they are not linear. So what you do is you find those differences, and then you take the difference of these. So from a -3 to a -1, I actually am increasing by 2. From -1 to 1, I'm increasing by 2, and from 1 to 3, I'm increasing by 2. So this shows me, since the second differences are equal, this is going to be a quadratic function. So we're going to go ahead and look at some tables and decide what they are. So when I look at this first table, I do need to check out my x's and make sure that their increments are the same, and these x's are all increasing by 4, so it's good. And now I'll look at the differences here. So from -1 to 0, I'm increasing by 1. From 0 to 1, I'm increasing by 1. 1 to 2 is 1. 2 to 3 is 1. So the first differences are equal, so this one's linear. Here again, -3 to -2 increases by 1, etc. So my x's are good. And now I can tell my differences just by looking at this are not the same. So I don't really care that from 625 to 125 it's a decrease of 500, because it's clearly not a decrease there. So that's going to take me first to exponential. So if I take 625 and I divide it by 125, actually let's do that the other way. If I take 125 and divide it by 625, I get 1/5. If I take 25 and divide it by 125, I get 1/5. If I take 5 and divide it by 25, again I get 1/5. And then 1 divided by 5 is 1/5. So all of these have a ratio of 1/5. And when they have equal ratios, they are exponential. Next, I know that this is quadratic, and I know you do too, because you can see the vertex and it's symmetric, but I still want you to humor me and show me these differences. From 7 to 4, it's a decrease of 3. From 4 to 3, it's a decrease of 1. From 3 to 4, it's an increase of 1. And from 4 to 7, it's an increase of 3. So there's the first differences. Now I look at the second differences. From -3 to -1, it's an increase of 2. From -1 to 1 is an increase of 2. And from 1 to 3 is an increase of 2. Since the second differences are the same, it's quadratic. And let's try this one. Again, I understand that you can see it's quadratic, but I want you to show me. From -3 to 0, it's an increase of 3. From 0 to 1, it's an increase of 1. From 1 to 0, it's a decrease of 1. And from 0 to -3 is a decrease of -3. Evidently not linear. From 3 to 1, it's a decrease of 2. From 1 to -1, it's a decrease of 2. And from -1 to -3 is a decrease of 2. So again, this is quadratic. Alright, same thing here, except they're going to have us take it a step further. Tell whether the table of values represents a linear function, an exponential function, or a quadratic function. Then write the equation for the function. So I'm looking at this one, and again, my x values are all the same interval. I can tell that's not exponential because it doesn't look like there's a ratio. So I go from -7 to -5 is an increase of 2. From -5 to -3 is an increase of 2. -3 to -1 is an increase of 2. And right here from -1 to 1 is an increase of 2. So this is linear. So my goal is to get it into slope-intercept form. And my slope is actually 2, because that's what it's changing by. Since all of my x values are changing by 1, and my y's are changing by 2, the change in y over the change in x is 2 over 1. So that gives me a slope of 2. My y-intercept, I'm lucky enough that it's right here. Remember, the y-intercept occurs at the y value when x is 0. So the y-intercept is -1. So the equation for this linear function is y equals 2x minus 1. Again, I can tell this is linear. I mean, not linear, exponential, but we're going to prove it. So this is a decrease of 6, a decrease of 2, an increase of 2, and an increase of 6. This is now an increase of 4, and 4, and 4. So it's quadratic. You're just going to get basic quadratics. So your quadratic that we're shooting for is y equals ax squared. You're going to see that all of the ones that you have for this particular lesson, you're not going to have a b value or a c value that are not a 0, so we're okay with that. In Algebra 2, you'll take it a step further. But we need to figure out what the a value is. So this is what we're going to do. We're going to pick a point, x and y. You don't want to choose 0, 0, but you can pick any other point, because 0, 0 wipes everything out. I'm going to go ahead and just for grins pick 2 and 8, because I'm searching for the a value. So my y is 8, my a I don't know, but my x is 2. So I'll go 8 equals 2 squared is 4, so I get 4a, divide by 4, and a equals 2. So my quadratic function is y equals 2x squared. And you don't have to put in plus 0. You can see that the y-intercept is 0, but you should at least check it. So if I put this in, -2 squared is 4 down here times 2 is 8, so that works. Negative 1 squared is 1 times 2 is 2. 0, everything zeroes out. 1 squared is 1 times 2 is 2, and we already checked it with this, so it does work out. So y equals 2x squared. Okay, last one. The value V of a printer between 1999 and 2003 is given in the table. Tell whether the data should be modeled by a linear function, an exponential function, or a quadratic function. Then write the equation. So again, all the x's are increasing by 1, and it appears that my y values right here from 2000 to 1920 is a decrease of 80. And these are all decreases of 80. 1920 to 1840, 1840 to 1760, and 1760 to 1680. So this is linear because the first differences are the same. So I'm looking for, instead of y, I'm going to go v of t equals mt plus b, slope-intercept form. So v of t equals my slope. Again, it looks like here they were nice enough to have the years increase by 1, so the change in y is negative 80 as x changes by 1. So my slope is negative 80 t plus my y-intercept is right here, 2000. So it appears that the value of the printers has been going down by $80 since 1999, and the printer actually started at $2,000 in in the year 1999. So big difference between a printer now and a printer back then when they first started. All right, that's it as far as your notes are concerned. Your lesson that you're going to do is 9.8 worksheet B, and I will have those printed out for you.